Welcome. It's already week 3. Yeah, I think I should do something about this. I mean, me making the same comments on my previous lecture and then doing this again, 2:30 and 4 o'clock. I opened the lecture with the same joke or same comment or whatever. I was going to comment that it's spring, so the people's clothing have become a lot more colorful, but oh well. Anyway, now, last lecture we talked about utility, and we kind of talked a little bit about how this utility function has a long history of it being a cardinal concept. Great, 최대 다수의 최대 행복 얘기했었죠. Greatest happiness for the great number of people, etc., etc. But the fact that only the order matters in the current context of economics. What I meant by that was essentially that whether I prefer, because it was a major primary day today, whether I prefer Donald Trump to Ted Cruz or Ted Cruz to John Kasich, or now that Mark Rubio dropped out, there's no other choice there. That is important, but it doesn't then matter how much I prefer Donald Trump to Ted Cruz or Ted Cruz to John Kasich, whatever. Now, so essentially we kind of dealt away with this cardinal aspect of how much I prefer. We can't really measure and compare each person's happiness with another person's. That's the, I guess, limit we have to accept as economists now. So essentially, nowadays, utility function is just a number. It's just a way of representing your preference, nothing more, nothing less. That number doesn't have an intrinsic meaning itself, okay? Now, so utility function, this is where we talked about today. As long as the ordering is the same, you are talking about the same preference, okay? Now, when we begin to talk about risk, uncertainty, and add different possibilities of the future into it, we're going to have to talk about something different then. But for now, we'll be fine with this notation for now. Okay? So this is where I stopped the lecture on last Friday. That monotonic transformation. If 2, 4, 6, 8, these numbers represent the same utility, same preference relationship, then so should 200, 400, 600, 800, or 0.2, 0.4, 0.6, 0.8. In other words, what I'm saying is that there is no unique way of describing 이경재 학생's pleasure, 노진우 학생's pleasure, each person's preference relationship, and that's much better now. Okay, so we're going to talk about a few examples in the first half of the lecture, and then we're going to move on to optimal choice thereafter. Okay? Now, perfect substitutes. What example did I give you? Pen. Or another example I gave was fabric softener, right? The concentrate version against the normal version, right? That the concentrate version is chemically same, but you only need to put in about 10 ml and then they'll do the wash, whereas the normal version would take about 50 ml to do the washing. And so I'm just trying to contain my anger a little bit when the word laundry came up, and the fact that people living above me in my apartment did laundry at 1:20 in the morning, and I had to knock their door so hard. That's one of the reasons why my daughter woke up and they wouldn't let me sleep for after. Yeah. Anyway, let's move that on. Okay, so perfect substitute means it doesn't matter whether you use one thing or the other thing. It gives you the equal amount. You can perfectly substitute one good for another. That's what I mean by it. 10 ml of fabric softener doing the washing is same thing as 50 ml of normal fabric softener doing the washing. So it's just like a straight line. We talked about this before. The indifference curve should be a downward sloping perfect line. Now, can you suggest a utility function that would give you this sort of indifference curve? So we have x1, we have x2, and the indifference curve looks like this. My question is, what type of functions would have this sort of property? Linear function, how? So just give me one example. So x1 is, say, the concentrate fabric softener. Something like this. Yeah? 1 ml of concentrate gives me 5 times the concept of fabric softener giving you pleasure in any way, sort of form is weird. But, okay, again, satisfaction is not the right word to use here. But, okay, so 1 ml of concentrate fabric softener does 5 times the same job as 1 ml of normal thing, right? So, something like this, okay? Now, one good thing about fabric softener is that if you're short of concentrate, you can mix them up with normal version. So you can put in, say, like 5 ml of concentrate and then 25 ml of normal version. That will perform exactly the same way as 10 ml of concentrate or 50 ml of normal stuff. That's what perfect substitutes are. So it's like a very linear function with constant marginal rates of substitution. Now, remember, when we talked about indifference curve last week, and especially well-behaved preferences, well-behaved indifference curves, what did we find? There was one thing that we imposed. Does anyone remember? It was the diminishing marginal rate of return that was the key. Now, who did I talk about? I think it was Tracy or someone else I asked that said, if you have to live for a week on sushi or cream pasta, if you're consuming a lot of sushi, then you're willing to give up a lot of sushi dishes to obtain something different. Raw fish just makes me feel really bad now because I've got too much of it. But having that pasta dish would relieve me of this living on Japanese for a week already, yeah? But when we go to a place where we're consuming a lot of pasta and just a little amount of sushi, then you're not willing to give up sushi to have more pasta because you already have a lot of pasta. So that's why we had an indifference curve like this with the slope steep at first, but gradually becoming less steep. What that meant, average is weakly or in some cases strictly preferred to the extremes. Thank you. So your name is? Okay. So what I mean here is that essentially what I'm saying, what this indifference implies is that sushi and pasta are not perfect substitutes. Yeah? If they were, then clearly you would be indifferent between having 7 nights of sushi in a week or 7 nights of pasta in a week. Monday, Tuesday, Wednesday, Thursday. But you're not like that, are you? The fact that I mean, Taco Bell is not exactly Mexican, but we're gonna let that go. Let that one go, okay? Now, point is, generally, when I was on Between, which is one of the apps Koreans use, with my wife earlier and said, what are you going to have for dinner? And then the first question I asked was, what did we have for dinner? A, that shows you how much of a memory loss I've had. And B, it tells you that food or different dishes are not exact substitutes of each other. Yeah? If they are, it shouldn't matter what I had yesterday. 나 어제 중국 음식 먹었어. I had Chinese yesterday. I'm not willing to have another jjajangmyeon. No, 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 no. It's not like that. If they were perfect substitutes, then we'll be indifferent between having pasta or sushi night after night after night after night. So the sort of a linear utility function, a linear indifference curve we get is a very restrictive assumption. We don't get that a lot in usual context, okay? Now, we also had something called perfect complements, correct? Okay, so that's a nice example of perfect complements to printer toner and printer, car, gasoline. That's good. Now, what sort of mathematical function would give you an indifference curve like that? Exactly, right? The classic example that you see in textbook again and again and again is the left shoe against the right shoe, right? Yeah? So if you've got 7 left shoe but 1 right shoe, it's absolutely useless. You have only 1 pair to wear. But if you have 3 left shoes and 300 right shoes, that's not that useful either. It's that you have to consume both goods in pre-specified fixed ratios. So that's what we mean by min. So my printer, for example, has to take 4 toners each at the same time for it to work. 1 black, 1 cyan, 1 magenta, 1 yellow. Yeah? Then I would write like if x1 were the printer and x2 were the toners, essentially I'm requiring this, right? 1 printer, 4 toners. If you deviate anywhere slightly further from this relationship, you're not going to get anywhere. You know, having a stack of toners is absolutely useless if you've got no printer. Yeah? So that's what we mean by perfect complements. But convex preferences are the ones that we always talk about again and again and again. What sort of utility functions would give you that? Well, clearly, there are lots of different possibilities, but the one thing that we use most often are called Cobb-Douglas function. It's named after an economist and a senator, US senator, who had his name ingrained in the history of economics forever, which is quite unusual. But the economist Cobb was the economist, Douglas was the senator, I think. Could be the other way around. Did a joint analysis of US economy based on the assumption that people's preferences took that shape. Okay? So utility of x1 and x2 under the Cobb-Douglas function are given as this sort of a power function to the power of c to the power of d. Now, however, what I said about monotonic transformation comes in really useful, okay? What if we do that? Does the order change? Assuming C and D are positive, does the order of your preference relationship ever change? Yes or no answer? No, right? If x1, x2, a bundle x1, x2 was bigger than y1, y2, it will be bigger if you take c plus d, 1 over c plus d power and both ends. What I'm saying essentially is, if this were true, then clearly this should also be true, right? Order shouldn't change. The preference relationship will be captured by this or this, and there's no way of distinguishing between the two hypotheses. But if you do this, then essentially you can write it slightly differently like this. Yep? Because they add up to 1. Okay? generally we only deal with Cobb-Douglas utility functions that across a number of different goods, if you add the power together, they add up to 1. That has an incredibly useful property that I'm going to come back to if I have time in a couple of weeks' time. And if you take my financial econometrics lecture, you will definitely see why that is the case. So once we have the utility function, if we know the utility, then now we are at a place to talk about something called a marginal utility. Yep. In other words, how much does a consumer's utility change? How much does your happiness, does your satisfaction, pleasure change if we give you just a little more amount of, say, good 1 or good 2? Okay? So marginal utility is defined as follows. How much does your overall utility function change following a little change in your good 1, x1? Okay? So utility of x1 plus little amount of extra x1 minus x1. So following that x1 change, if I get little more, one more dish of that sushi, or one more dish of that pasta, okay? How much does my utility change? So clearly, if you know calculus, but I mean, most people here have basic understanding of calculus, right? Then it's just the first partial derivative of utility function with respect to x1. So that's where the marginal utility and the concept of calculus comes in. Every time you hear the word marginal, or in Korean, 한계 뭐라고 나오면요, it's saying do the first derivative. Always. Always, always, always talk about it, because 한계 means at that point, how much does a little marginal change your whatever objective function or whatever. That can only be found out using the first derivative of the function. Okay? So, notice that this is your definition of marginal utility, right? What I mean by that is the total change in your utility or your satisfaction or your pleasure following some extra amount of x1. I don't know, be it soap or shampoo or whatever, is the amount change in x1 times the marginal utility. You can do this without that much trouble, right? Now, let's go back to the indifference curve, and now we can define the marginal rate of substitution and close the model. Okay? Because what was the definition of marginal rate of substitution? Anyone willing to have a go? It can be in Korean or English, and can I try and give someone else the opportunity? So, how much x1 do you have to give up, x2 do you have to give up following a little increase in x1? Would you be indifferent as before? Or, put it another way, suppose someone takes away a little amount of good 1 from you. How much does that person have to compensate you in the form of x2 to make you feel as happy as before? So Lee-Kyung-jae saying, for example, may feel, I don't know, suppose that we're talking about 2 goods, say, and then say, suppose I were to snatch the glass of 맥주 in front of you. I then ask, the marginal rate of substitution, tell me, how many glasses of whiskey do I have to give him to make Lee-Kyung-jae feel as happy as before, right? What that means is this. The change in utility function following me taking away that x1 from him will be what? This. Delta x1 times marginal utility, assuming that change is small. Okay? But that's not the end of the story. I now compensate Lee-Kyung-jae with good 2. Okay? That's going to give me, that's going to boost his utility a little bit, somewhat, somehow, okay? So that's going to be this. What I'm saying is that if I've done that, if I finish that, take away x1 and give him x2, so in change terms, what should this equal? If I add these two together, they should be 0, correct. So that's the reason why, well, clearly, watch this. That's the slope of the indifference curve, which therefore is the marginal rate of substitution. 한길의 치율이 이겁니다. But now MRS is expressed in the form of the relative ratio of two marginal utilities. That makes sense. That makes sense. How much you're willing to give up and trade between two goods, your subjective opinion, is going to be given by how much pleasure I get from good 1 and how much pleasure I get from good 2 and the relative ratio between those two goods. That's the reason why the slope of the indifference is given by the ratio of two marginal utilities. And that answers, I think, Anders or Raphael, one of you asked questions about how is this related to the concept of marginal utility, right? This now answers your question. Marginal utility is the concept that links indifference curve and people's rate of substitution, their own rate of substitution. But there's one thing you should bear in mind, okay? Now, I talked about how useless utility functions are in the current context of economics. It's just a number, yeah? Monotonic transformation, etc., etc. Correct? One thing that is useful, however, is MRS. MRS has to be unique, even if MU2 and MU1 are not unique. Because any monotonic transformation affects both the denominator and the numerator, so the effect cancels out. So if we want to talk about good A and how much that good A gives pleasure to me or satisfaction to me, that is a useless concept now. But the rate at which I am willing to trade between two goods, so now the perspective of microeconomics has moved everything to the relative. How much do I prefer sushi relative to pasta? How much do I prefer chimek relative to 보쌈 and soju? I said I would stop talking about food, but clearly I'm incapable of talking other than food, so I'm going to give up on this, okay? Or how much do I prefer, I don't know, a Gap clothing to a, I don't know, DKNY, okay? So that's why we always talk about the rate of substitution, the relative substitution rates between two goods, and not talk about one good and one good only. Everything is in relatives. So when this sort of microeconomic analysis is useful only when we talk about things in relative terms, not on absolute terms. This is where I want to focus a lot more on. And we're going to talk about optimal choice today, and we're going to talk about the implications of that optimal choice. And I don't think I'll go through the entire material until Friday, so we're going to have a little bit of a spillover to next Wednesday, and then I'm sorry to say, but next week's lecture is going to be a hell, because the most difficult part of the lecture course before the midterm exam, and it's such a good material to write trap questions for you to do. Everything arises from this simple fact called the optimal choice, okay? Now, over the past 2 weeks, we learned about budget constraint, we learned about theory of preferences, but now we are at a place where we are equipped with enough knowledge and enough concepts to go back to our basic economic problem. I think I've asked you at the beginning of every lecture for every past 2 weeks, what's the basic economic problems? I'm not going to do that again. But essentially, it comes down to what's the most affordable good that gives you the greatest amount of satisfaction. The concept of affordable is ingrained in the budget set, the budget line. How much satisfaction you feel is in the indifference curve. So if you add them together, now we can talk about optimal choice. What's the best choice for you? Okay? So a typical case is illustrated in this page. I'm just going to do this graphically first, and then we're going to derive it mathematically later. Okay? So suppose we have a consumer with the budget set like this and indifference curves like that. Okay, suppose you're consuming here. Are you using up your budget or not? You are. Why? Because that's on the line, yeah? But are you being optimal? Why? Because by moving somewhere else, more specifically to here, you can increase your utility, your pleasure, your satisfaction. So what's the key condition that you're going to have in this sort of case? What's the most important condition in this sort of, for this type of consumer? The budget set and the indifference curve both have to be, finish the sentence please. One word I'm looking for. Top. See, if I talk in Korean, they can come up with the same word. The English word you're looking for is tangential. The point of tangent. Yeah? Now, when we talk about tangent, we only think in terms of sine, cosine, tangent, and our mind is just fixated on that, and that's the main problem, right? But English word you're looking for is tangential to each other. Top, jump. Yep. Why is that point the consumer's optimal choice? Because it allows the consumer to attain the outermost, the most outward indifference curve and satisfy the budget constraint at the same time. Yep. So the most important feature is that it is tangent to the budget. So it was on the PPT all along, yeah? Just the next slide, at the point of optimal choice. But we'll come back to this in a moment. But in the case of well-behaved preferences, that carries an important meaning. Okay, I'm going to talk about this. I'm going to come back to you later, and then I'm going to talk about that again. People's subjective rates of substitution are equated to the market's objective rates of substitution. 주관적인 트레이드 레이시, 대체율이 객관적인 대체율과 일치하는 지점이다라고 얘기를 하면 뜻이 많이 달라집니다. That's philosophical. Okay, okay. Let's dwell on that for a bit now. I'm not going to wait till like say next week or anything like that. Okay. What that means, everyone, is you can be rich or you can be poor. You can be incredibly rich or you can be incredibly poor. And the amount of pleasure you get will be different. The total amount. Warren Buffett or Mark Zuckerberg will be likely much happier than we are. That's a sad thought, but that's the fact of life. Well, one thing for sure, they'll derive greater amount of pleasure from the goods you consume, the total amount. Suppose that good A is travel abroad, and good B is, I don't know. I say so good A is a plane trip, good B is, I don't know, a nice bottle of wine, Chateau Lafite, or I don't know, Chateau Margaux or something like that, okay? It's one of the most expensive wines in Bordeaux, by the way. Chateau Margaux 82 sells for about 6 million Korean won, or about $3,000, $4,000. Okay? Yeah. Now, my point is this. Even though the total amount of pleasure that Mark Zuckerberg or Warren Buffett or whatever derives from traveling in first class on Etihad or drinking a nice bottle of Chateau Petrus 1990 or whatever are going to be different from us traveling on economy class, changing over twice, Seoul to Tokyo and then Tokyo to, I don't know, Kazakhstan somewhere, and then getting to Prague on your backpacking trip, and then drinking a $7 wine in Prague, whatever. The total amount of pleasure you feel will be different. My point is, in equilibrium, the market rates, the relative price you face in the market between plane ticket and wine will be the same for everyone. Correct? What does that imply about everyone's relative rates of substitution? I haven't said anything about absolute. Relative. It's a one-word answer I'm looking for. Every person that participates in that market, 그 시장에 참여하고 있는 모든 사람들의 상대적인 대체율을 묻는 겁니다. 항공권과 엄청나게 나이스한 와인 간에. How should they be? What should they be for everyone? The same. That's an important philosophical discovery of this optimal choice. Everyone. What I mean by that is people will adjust their consumption accordingly so that their own rates of substitution, I'm willing to give up this many bottles of wine to go to Europe on second class or whatever flight this summer. Or I don't care about travel abroad. I'm really worried about terror. I much prefer just saving up 200,000 won and then just splash it on a nice bottle of wine with my boyfriend on my second year anniversary or whatever. Okay? That's all good. That's all fine. But that rate of substitution should be the same for everyone. You will all each individually have adjusted consumption so that if you're facing the same price in the market, what that means is I don't need to know about your individual preferences. In equilibrium, implicitly, I know that 노진우 학생, 왕이지 학생, 김정숙 학생, 전선 학생, whatever, everyone's marginal rate of substitution between flight and wine will be the same because they face the same price. 이거 되게 심오한 거예요. sorry, just in Korean for 1 minute. 내가 얼마만큼의 와인으로부터 또는 항공권으로부터 만족을 얻느냐, 총량에 대한 거에 대해서는 얘기 안 합니다. 잘 사는 사람이 당연히 더 그렇겠죠. 근데 시장에서 내가 보는 가격, 상대 가격은 항상 똑같아요. 한주선 학생이라고 해서 와인을 안녕하세요 되게 막 이렇게 해서 반값에 얻을 수 있고 이런 게 아니라면, 모두가 똑같은 가격을, 상대 가격을 제시받는다면 내가 알아서 내 소비를 바꿔서 균형에 도달한 지점에서는, 옵티멀한 지점에서는, 최적의 지점에서는 여러분 모두의 relative rate of substitution, 내가 와인 한 병과 항공권, 해외여행 항공권 간에 얼마를 포기하겠는가의 그 비율이 묻지 않아도 다 안다는 겁니다. 유영석 학생에게. 그 누구의 것들도 다 똑같을 거란 거예요. 왜? 시장에서 제시된 가격이 옵젝티브하게 있고 객관적으로 있고 여러분들이 최적화를 하는 바보가 아니라면, 합리적으로 행동하는 사람들이라는 가정만 하고 있으면 알아서 여러분들이 그거에 맞춰서 여러분들의 소비를 바꿀 것이기 때문에. That's the beauty of MRS. That's the beauty of optimal choice. That's important. I don't know. I don't observe. I don't know what 주영빈 학생 does in spare time. I don't know what 유영석 학생 does in spare time. I don't know what Melissa does in spare time. I'm not interested. Okay, I mean, as a good teacher, good lecturer, as a good listener, I may be, but leave that aside. I'm not interested as an economist to what each individual's preferences are. All I know at that optimal choice, optimal point is that people facing same set of prices will have the same relative rate of substitution between two goods. Now, the reason why I'm highlighting this a lot is due to my personal experience. I did my undergraduate degree in England, obviously, and this damn equation comes up year after year after year, okay? One in mathematical form, or be it intuitive graphical form or whatever. Did it in high school, did it in my first year, did it in my second year, did it in my third year. I taught this throughout, but most of the time we just said MRS equals the slope of the budget set and then we move on. We don't talk about the implications of that. But implication is the key. What that means is important. If you know that, that's going to be the interesting point. If not, it's just going to be the five point on the exam. Oh, I need to know how to draw this. I need to revise this. But assumption and what we can get from that intuitively is important. I only realized this probably in my about third year PhD when I was teaching as a TA. And then every time I talk about this to students to just really nail you, get you focused on that, the importance of what we mean by MRS equals relative price. That is important. That really is important. Okay? But it's not guaranteed that we will have such a nice tangential, 여러분들 30명이 한꺼번에 우리말로 하세요라고 하자마자 접점이라고 얘기했던 그곳으로 가지 않을 수도 있습니다. We don't have to have interior solution all the time. And the most important two examples that we are going to come across are perfect substitutes and perfect complements. Then we're going to have something called a corner solution. Okay? Right. And the key, again, before I go on, the fact that it's a point of tangency or 접점 doesn't guarantee that it's going to be an optimal point, okay? It's a necessary condition in certain cases, but it's never a sufficient case unless we have truly well-behaved convex indifference curves. 무차별 곡선이 얌전하게 볼록하고 그 모양이 아니라면 the fact that it's a point of tangency doesn't guarantee that we are having an optimal point. Yeah? These points are optimal. They are the most outward indifference curve you can attain. This point, however, it is tangential. It's not a point of optimal consumption, is it? So bear that in mind. But let's move on to perfect substitutes first. Okay? So this is my budget set. But my rate of substitution is different from budget set. And it's constant. Suppose the slope here is -2 and suppose the slope here is -5. They're never going to be tangent ever again. So you never ever have an interior solution in this case. 내부에서 안 만나겠죠. 절대 접점이라는 게 있을 수가 없겠죠. 그죠? So you're going to look for a corner solution. And that point is going to be the optimal bundle. But what's the intuition behind that? How do you justify, how do you rationalize that? Yeah? So let's go back to the fabric softener example that I've been on and on and on about again. Okay? Now I said 10 ml of concentrate bottle does 1 washing. 50 ml of normal fabric softener does 1 laundry again. So if I give you 1 liter bottle of concentrate and 1 liter bottle of normal, Using concentrate, how many more laundries can you do? 5 times more, right? If you can do 20 laundries using normal, you can do 100 times with, what's the word I'm looking for? Concentrate. Sorry, 2 hours of sleep last night. Yeah. Okay? Now, however, if they don't sell at a rate of 1 to 5 on the market, clearly one's cheaper than the other. That's my point, right? Think about it. If you can do 100 laundries with concentrate and 20 laundries with normal, but they sell at the same price, what are you going to go for? You're not going to mix them up together. You're going to spend all your money allocated for fabric softener using concentrate only, right? On the other hand, if your concentrate bottle, 1 liter bottle, is, say, 10 times more expensive than the normal bottle, but only allows you to do 5 times more laundry, what's better? Normal one, not the concentrate one anymore, right? So you're going to be spending your entire expenditure on only one good, generally. Unless the relative price happen to exactly equal your rate of substitution between 2 goods, which is highly unlikely, generally there will be one good that is cheaper than the other. Using the pen example, it doesn't matter whether I use the black pen or the blue pen. But then student says, okay, you can borrow my pen for 500 won if it's black, 1,000 won if it's blue. Clearly, I'm going to go for the cheaper one, right? I'm not going to mix them up together. I'm not going to derive any extra pleasure from writing the first line of my immigration form in black, then second line in blue, and then third line in black, then fourth line in blue, anything like that. That's just going to make you look weird. Nothing else, right? So you're going to be spending entire expenditure on the good that is relatively cheaper. Budget set is like that. Your indifference curve is like that. So compared to your own rates, the market is offering you a more favorable rate on good one. That's why you're spending the entire money, entire expenditure, the entire money you have on only good one. You're not going to mix and match. You're going to go for that. That leads us to some of the well-known anomalies, like why do people tend to buy cans of Coke or Sprite, even though the 500 ml bottle exactly the same, nothing different in. I mean, some people claim that, oh, it tastes a little different from the aluminum can rather than the bottle. Bollocks. No, it's not. It's the same Sprite, same Coke. And yet, if you go down to CU or 사자가 군것질할때든가요? 이름이 도대체 누가 그 이름을 지었는지는 모르겠지만, 그죠? And look at the price of 330 ml can and 500 ml bottle. They're not going to be priced at a rate of 1.67, right? They're not. Sorry, 1.5, isn't it? No, they're not going to be priced at a rate of 1.5. Or if you buy Samdasu, which is a Korean water brand, the most standard Korean water brand, water from Jeju Island. If you buy 500 ml bottle and 1.8 liter bottle, they're not priced at a rate of 5 to 18. Yeah? 500원, 1,800원 아닐 겁니다. 분명히 아닐 거예요. So if you're rational, then you should probably stock up the one that is relatively cheaper. Now, I can understand why you might not do that for Coke or Sprite, especially if you're living alone. If you're really sad, you don't want to meet anyone, you're stuck at home and you're just on League of Legends or Football Manager constantly for hours and hours, then the fact that you have a 1.8 liter PET bottle means you might feel like, oh, I've opened this, I've really got to finish. I have a real tendency to do that, yeah? That's why whenever, that's a great example, by the way. Whenever you order pizza from Domino's or whatever, Mr. Pizza or wherever, notice the price between 500 ml bottle and 1.5 liter bottle of Coke. There's a very little difference. And yet I always go for the 600 ml bottle because I always say to my wife, look, if I open this, I feel like I have to finish it. And besides, it's going to go off after about a day. You know, it's going to be really stale and it's going to be really bad. And Coke tastes like random sugary water with weird color. Yep. So I can understand that. In that case, you're not treating it like a perfect substitute. But what I, as a consumer, cannot understand is water is water. Water doesn't go off. So that's as close to a perfect substitute as things get. And yet people continue to buy the relatively more expensive, smaller bottle. I don't see why. I can see that. I can see that in the case of, like, say, like if you're living alone, don't have a car and go to a mart and just like carry like that individually, then yes, I can. But if you're driving on, say, your Sonata or K5, you're doing your weekly shopping, then you're just going to carry them home on a cart. Can anyone come up with just conceivable explanation? I'm just out as an aside. Can anyone come up with a rational explanation of why we would buy 500 ml bottle of Coke? I can understand. You open the bottle and it goes off. But water is not like that. Why would you go for the relatively more expensive small bottle? I'm asking you as a... Huh? Refill water. Yeah, okay. Small bottle. You can, but I lived on 1.5 liter Volvic in my university days. I would carry it, refill it, and then... Okay, in that case, what I propose to you is buy one bottle of the small bottle, then fill up the rest with the big bottle, and then refill using larger one. Yeah. So why? Or just buy what do you call a tumbler, which is better for you environmentally, right? Can anyone come up with an? I mean, we're trying to have a discussion here. Can anyone come up with an explanation of why that might be the case? 없어 요가 끝이 아닙니다. 어차피 이거는 그냥 행동 경제. No right or wrong answer here. Why would you do that? I mean, we do that as a student, as consumers, right? Why do we do that? So you're saying that the small bottle of water you can have cold straight away, but big bottle of water, a large bottle of water, you have a little bit cold and then it'll go really warm and you have to carry it around for the rest of the day. Yeah? So notice how difficult it is to have a perfect substitute in reality. Yeah? Same water. And yet you're evaluating this differently, right? So in reality, it's damn difficult to have a perfect substitute. That's what I found out when I was teaching at the Cadet Academy. Like, for example, you get given uniforms. 노진우 학생 같은 경우에도 전투복 있죠, 어딘가에. 그죠? Right? You have the combat uniform, you have the right uniform, and then people always talk about tuning the uniform and or the buying the 싸제라고 합니다. 남자분들 아시죠? Or buying the private stuff that is not rationed to you. Same thing, but that's why in reality finding this perfect substitute is a really difficult task. Okay? So I've written this down, but we've done more than our fair share of discussion on that already. So let's now move on to perfect complements. Notice that you don't get a point of tangency here either. Where will you consume? You're going to buy one printer and 4 turners. You're not going to buy 10 printers and 1 turner, even if you have the money. It's better off buying 5 printers and 20 turners and then distribute to 5 people. You have a printer, you have a printer, you have a printer, etc. Yep? So here we have another corner solution. Yep. There, the marginal rate of substitution will not equal the slope of the budget constraint either. But it's the shape of the utility function that does that. Okay? So you always be consuming at a pre-specified rate. Army is especially, particularly good at that. You get one gun, rounds of 30 bullets, 5.6 mil bullets, or whatever, one beret, two combat uniforms, one normal uniform, etc., etc. Those who've been in the Army will testify to this, right? Or Navy, or Air Force, or Marines. Yep. No preference over there. Okay? But this condition, in other words, marginal rate of substitution equaling relative price is only relevant for the case of well-behaved preferences. Okay? Well-behaved preferences. So we can talk about optimal choice of good 1 and good 2 at given prices and income. So, in other words, we've talked about this graphically until now. 그래프로 보여줬죠. But they are all expressed. The optimal bundle can be expressed as a function of P1, P2, and income. That's called your optimal demanded bundle. And now, my analysis over the next week and a half will only focus on this demanded bundle. The beauty of the whatever I do next will be what happens if you change income? What happens if you change prices? And everything will follow on from there. So we're going to be engaging in what in English we call comparative statics 또는 그러니까 정적 비교라고 하는데요. So that's what we're going to be doing. Okay? So, for example, in the case of perfect substitutes, I said it can be represented by the utility function like this. 5x1 plus x2. Yep. Now, if the price of concentrate is more than 5 times the normal one, so it allows you to do 5 times more washing, but costs, say, 100 times more expensive. No one's going to buy that, right? So your entire demanded bundle is going to be 0. You're not going to buy concentrate at all. Okay? Or if your concentrate bottle is relatively cheaper than the normal bottle, then you're only going to be buying the concentrate only, entire income. So you're going to be spending one corner of the equation where you're spending the entire amount on good 1 or entire amount on good 2. With that course at the end of the lecture, sorry. Yeah. And if the ratio is the same, in other words, concentrate bottle sells for 5,000 won and normal bottle sells for 1,000 won, the ratio is exactly the same, then you can buy whichever one you like. There's nothing wrong with that. But what I'm saying is, again, going back to that 삼다수 example as well, if there's a relatively cheaper one, you should be spending all your money on that relatively cheaper one. If you're not doing that, clearly I am saying there is something wrong about it. It's not a perfect substitute. That's the reason why I try to engage you in thinking, why would same 삼다수, large bottle, small bottle, be viewed differently by different people? Always question that, okay? Or perfect complement-wise, how would you consume? If you have, suppose if I have about 1 million won in 연구비 or research money, and I have to spend it on printer and toners, how am I going to do this? Clearly, I'm not going to buy 500 toners and no printer, or 500 printers and no toners, right? So if my one printer requires 3 toners to work, then I always be consuming at a rate of x1 and 3x2. So I'm going to be spending 3 times the amount of printer on turners. 1 printer, 3 turners. 2 printer, 6 turners. 3 printer, 9 turners. Get that, right? So I'll be maintaining that ratio throughout, and might divide the income to see how much I can satisfy that ratio. Yep? 1대 3의 비율을 맞추면서 내 가진 돈으로 살 수 있는 가장 많은 거를 사겠죠. So that's why you're going to be having price of printer plus 3 times the price of toner is going to be what you're going to be spending on one set of printer toner, right? So I'm going to be dividing my income into that amount of combined price, if you like, and then I'm going to be spending that amount on printer and 3 times that amount on toners. So 1 printer, 3 toners, or I don't know, 4 printer, 12 toners, or whatever.